Today, let's try to solve another Leetcode problem, 1339, maximum product of splitted binary tree. So we are giving the root of a binary tree, but we can split it from any two nodes. So for example, from node 1 and 2, we can split it to sum of 11 and 10, and the product is 110, and it is the maximum. Yeah, and the sum of 2, 4, 5, it is 11, and 1, 3, 6, it is 10. We can also cut from other places. For example, we can cut from the 5 or 4, yeah, or 1 and 3, and 3 and 6. Yeah, we can always cut like that. But we need to calculate the maximum product of the sum of two components. Let's analyze the problem first. So let's check the value of n is 5 times 10 to the power of 4. So we have to use maybe 1 or 2 loop. We must use on time to get the final result. And also for this binary tree, we are giving a root and we are also giving a binary tree. We can calculate the total, the sum of all the nodes. So for example, 1, 2, 3, 4, 5, and 6. So the sum of them will be 21. Yeah, basically we can use any kind of traversal or like post-order traversal, pre-order traversal, in-order traversal, or level-order traversal. But we can use any kind of traversal or DFS to solve the problem. We can get the total of all the node. Yeah, so the total of the node will be 1 plus 2 until 6. It's gonna be 21. So for the next step, we're gonna check what if we can calculate only this node 4. So the result will be 4, and what's left behind is 21 minus 4, it is 17. If we can calculate something like this. Or what about if we can calculate the 5? We can only get the 5, and what's left behind is only 16. And we're gonna calculate the maximum of all those results. But inside the recursive function, how can we directly calculate this node 4 or node 5 or 2, 4, and 5? Yeah, we can check the sequence of the calculations. So for the 4, normally its child is just 0 left and 0 right. It's going to be 0 plus 0 plus 4, it is 4. And also for this node 5, from the left it's 0, right side it's also 0. So 0 plus 5 plus 0 plus 0 plus 5, it is 5. And what about this 2? If we want to calculate the total, the current total, when it comes to this node 2, we have to calculate this 4 and 5 first, and then it comes to 2. So this is a post-order traversal. First calculate the left child and then the right child. But last, we're gonna calculate the root. So the value of the root plus the value from the left and right. So it's gonna be 11. If we can calculate this 11, we just need to use 21 minus 11. We get a value of 10. So 10 plus 11 is gonna be 110. If this is the maximum, we're gonna return this result. Yeah. Now let's use this kind of method to solve the problem. So first of all, we can use any kind of traversal to get the total sum. Yeah, the total value of all the nodes. So the sum of all nodes, we can use we just use a post-order sum to calculate all the values for the binary tree. We're gonna prepare a global variable. Let's define a self.total. Gonna be 0. Now we just use the post-order traversal template. So if node, so we're gonna use the self dot not self, because we just needed to use the post-order sum, node dot left, and post-order sum, node dot right. And after that, we just need to calculate the result. So self.total should plus equal to not.val. So this is basically a post-order traversal. After the post-order traversal, we get the result. So we can just call the function post-order sum with the root node. Yeah, and then we get the result. Let's put the global variable here. So currently we get the self.total. Yeah, before it's 0. After we call the post-order traversal, we're gonna get a result of 21 for this example. Now we're gonna use a second DFS. So it's gonna still be the post-order traversal. Let's copy the code from here. Yeah, it's gonna be similar. Yeah, because it's just a post-order traversal. Now we're gonna use a post-order max because we're gonna calculate the current max value. Before that, let's define a global variable of self.result and mod. So the result we can start with infinite value, negative infinite value, or 0. It doesn't matter because it will be bigger and bigger because we have at least 2 nodes. So we're gonna start from 0, and the mod should be 10 to the power of 9 plus 7. And we should note that you need to maximize the answer before taking the mod. So this means inside the calculation, we should not use modular. Only we need to return it because we need to maximize it. Yeah, you need to maximize the answer. In order to maximize the answer, we have to use a result modular, this mod. But inside the calculation, we cannot use the mod. Yeah. Now let's change the post order function. Yeah, because basically it's not the same. Now here we're gonna change it to post order max, and this is gonna be post order max. And let's check. So if not node, so this means if the node not exist, we're gonna return a 0. So for example, for 2, 4, and 5, when it goes to 4, it's the left child and the right child, there's no node. So we just need to return a 0. Then we can calculate the left and the right. So for example, for this node 4, the R should equal to 4, and for this node 5, the L should equal to 4, and this R should equal to 5. Yeah, we just need to put the code here. So as you can see, this is just a post-order traversal. As you can see the sequence, we first calculate the left value, and then we calculate the right value. So this L and R means from this node, the current total sum of all the values. So currently it is 4, and this one currently it is 5. Yeah. Now let's just use another variable. Let's use the self.result. Yeah, but before we get to the self.result, let's use the current sum or current max. Let's use current sum. Yeah. So the current sum would be the current node value plus this L and plus R. So this means for this node 2, the current sum is 2 plus this 4 and 5. This L equal to 4. Let's try to check this 4. So if we only have one node, so if not node, it is 0. So for the left side and the right side, it will still be 0. But for the current sum, it's gonna be 4. So this means finally, we're gonna return this current sum. As you can see, this is just a post-order traversal. But for this post-order traversal, we're gonna have a return of the previously calculated value, because for the next recursive function, we're gonna use this current sum. Yeah. Now, between the current sum and the return, we can update the result. So it's gonna be the max of self dot result with the current sum times total minus the current sum. Yeah, so for this example, if for the root node 1, for the left side, for this 2, 4, and 5, yeah, when it goes to this 2, 4, and 5, from this node 2, we're going to calculate the current sum. So it is 2 plus 4 plus 5, it is 11. And then we're going to update the result. It's going to be 11 times 10. It's going to be the maximum result. Yeah. So the return should be self.result modular the mod. Now let's just have a check if there's any mistakes. So the L and R and the current sum, and this is the self.result, and finally we're gonna return this current sum. Now let me run it to check if it works. So there's something wrong. Let's check. Yeah, so my output is 0, and I define a self.result as 0. This means I didn't call the function. Now let me call the function and check the result. The post order max, so I'm gonna use the root node. Yeah, now let's try again to check. The total is not defined. Yeah, because here should be self.total. It's a global variable. Yeah, now you can see it works. Now let me submit it before analyzing the time complexity. Yeah, as you can see, there are two recursive functions. So the reversal sum, it is On, and the second is post-order max, so it is still On. So the time complexity is On. And as you can see, it's also pretty fast. It's 50%. Thank you for watching. See you next time.